Okay, so for today's video, we will be talking all about elastic collision. So elastic collision is a type of collision where the two bodies don't have the same velocities after they collide with each other. So to further explain that, let's have here a sample problem. So I have here a bowling ball which is moving at 12 meters per second and has a mass of 2 kilograms. Then we also have here, so it hits a bowling pin that is initially at rest, so you have 0 meters per second, its velocity, and the mass of the bowling pin is 0.5 kilograms. So after the bowling ball hit the bowling pin, the pin moved in the right side of your screen. So you can see there that the velocity of the bowling ball reduced to 8 meters per second. So we are now tasked to solve for the velocity of the bowling pin. So the very first thing that we're going to do is to write everything else. So that means we have here before the collision and then we have here after the collision. So since we're talking all about the conservation of momentum, ibig sabihin nito that the momentum in before the collision and after the collision they're the same. No, there's no changes in the momentum or in the total momentum. So we say we have here the momentum of the bowling ball, let's say P sub B, before plus the momentum of the bowling pin, that's P sub P, then 1, that's before the collision, is simply equal to the momentum of the bowling ball after the collision plus the momentum of the bowling pin after the collision. After that, we simply try to go back to the origin of the formula of the momentum, which is m times v. So we say m, or the mass of your ball, times the velocity of the ball before. So that's v b sub 1. Okay? Then after that, we also have here plus mp. That means the mass of the pin times the velocity of the pin before the collision is equal to the mass of the ball, m sub b, times the velocity of the ball 2, meaning that's after the collision, plus we have here m p, meaning the mass of the pin, times the vp2. That means that is the velocity of the pin after the collision. So since when we try to go back here, the bowling pin is initially at rest. So when we try to get the momentum of this pin that is initially 0 meters per second, so there's no movement, so automatic the velocity is 0. So, we can cancel this out. That means that is just equal to 0. Kasi nga, not moving siya. So, we will only have MB, mass of the ball, and then VB1, meaning the velocity of the ball before the collision, is equal to M sub B VB2 plus M sub P VP2. So again, let me remind you, MB is the mass of the ball, and then the VB1 is the velocity of the ball before the collision. Then we have MB, the mass of the ball. VB2 is the velocity of the ball after the collision, plus MP, meaning the mass of the pin, times the VP2, meaning the velocity of the pin after the collision. So we are tasked to solve for this one. No, we are tasked to solve for that one. So what we're going to do now is to extract that. Okay, so the very first thing that we're going to do is to transpose muna that on the other side. So the formula now will become MB VB1 minus MB VB2 equals MP VP2. Now, since we're solving for the VP2, that means the velocity of the bowling pin after the collision, and then it is multiplied by MP. So all we need to do now is to divide both sides by MP, or the mass of the pin. Okay? So we have MP. We cancel this out, and our formula now would be MB VB1 minus MB VB2 over MP equals a VP2. 2. So that's very simple. This is now our formula. All we need to do is to arrange this in such a way where it's acceptable in the mathematics world. So ibig sabihin, dapat ito nasa kabila. So iguro na to siya ibaylo actually, no? We will simply exchange their positions. So this will now become VP2, or the velocity of the bowling pin after the collision is simply equal to MB VB1 minus MB VB2 over MP. So after this, you simply substitute all of the given. So the MB here is the mass of the ball, the bowling ball. The mass of the ball is 2 kilograms, so we simply write there 2 kilograms multiplied by your VB1. Your VB1 is the velocity of the ball before the collision. So before the collision, your ball is initially moving 12 meters per second to the right. No, 12 meters per second. So you have a positive 12 meters per second. Remember that if velocity is based on direction, therefore the momentum should also has direction. That's why we try to say if it's moving to the right or moving to the left. Since in this example the ball is moving to the right side of your screen, so it is positive 12, okay, minus MB, which is the mass of your ball, which is still 2 kilograms, multiplied by VB2, which is the velocity of the ball after the collision. So when we try to check, after the collision, the ball is now moving 8 meters per second. So we simply substitute that, still in the right side of your screen, so positive 8 meters per second, divided by the mass of the pin, MP. So the mass of the pin is 0.5 kilograms. So we simply put 0.5 kilograms here, 0.5 kilograms. Now, so that it will not be very difficult for you, you get your magic calculator and then you do the operation on the numerator first. So when you have here the 2 times 12, so in this case that is basically 24. 24. Now remember that kilogram times meter per second doesn't have a special unit. Ibig sabihin, if you multiply them, that's it. Okay? So you have here 2 times 12, that's 24. Okay? And then kilogram times meter per second is simply kilogram times meter per second. Minus, you have here 2 times 8, that's 16. And then kilogram times meter per second is simply kilogram times meter per second. Okay? So, divided by 0.5 kilograms. Now, all you need to do is to do the operation. So, we have here 24 minus 16. So, when you have your calculator, 24 minus 16, that would give you 8. Then you have here the units, kilogram times meter per second. So you have kilogram times meter per second divided by 0.5 kilograms. So in this case, you can cancel out kilogram because that would just be equal to 1. Okay? So you can cancel this and you have 8 divided by 0.5. That will give you 16. So your P2 is equal to 16 meters per second. Ibig sabihin, this is the velocity of the pin after the collision. So that's 16 meters per second. So when you try to go back here, we can now put here 16 meters per second. So that's how you can solve, or that's a way of trying to deal with problems related to this type of collision.